In this video we will see the tempering process. So when we quench steel, extremely hard and brittle martensite is formed, as we have seen earlier. So what happens is martensite is present, which is very hard and brittle, and also there is some retained austenite, which we will discuss in some advanced topic. And what happens is that retained austenite is very unstable. So due to that, there are internal stresses developed, and there is instability inside the material, and this martensite is very brittle, and so we have to resolve this issue so that our material does not break and also it remains stable. So what we do, it is therefore necessary to relieve the internal stresses, and for that we do this tempering process. So in tempering process, the heating steel below lower critical temperature, which is 727 degrees Celsius. So we first heat the steel, and then internal stresses are getting released by cooling it down, and then this process is called as tempering. So if we heat it, it again gets a time to grow its grain from very fine martensite structure. It starts growing, and then it has some ductility inside it, and some hardness is released. So the first is low temperature tempering, in which we heat it between 150 to 250 degrees Celsius, where we get ductility and toughness increased inside the material. So this process is used for cutting tools of carbon steels and alloy steels. So in this type of application, we use low temperature tempering, where ductility and toughness is introduced inside the material. In medium temperature tempering, the temperature increased to 350 to 450 degrees Celsius, where we developed a tool-side structure. We'll discuss these structures later, but here you have to remember that tool-side structures are more ductile than the structure present in the low temperature tempering, because temperature is high, so grain structure also gets much time and energy to regain its growth. So this application of this is coil spring, hammers and chisel, and hardness and strength are decreased and ductility increases. And also here endurance, strength and elastic limit increases, because in spring we require endurance strength. In endurance we have continuous loading cycles, so this kind of properties are increased. Will and In high temperature tempering, the temperature further increased to 500 to 650 degrees Celsius. So here the development of sorbite structure is there, which is more ductile than tool site, and this application are connecting rods of the automobile, gears, shaft, etc. And here removal of all the internal stresses happens, and there is high ductility obtained inside the material. So these three are the tempering processes. We will further discuss the remaining heat treatment and hardening methods. And thank you for watching this video. Do subscribe the channel and hit the like button. We'll see you in the next video.